Hi, everybody. You can hear me okay? Um, so this first talk I'm doing here, this one is API security testing for hackers, or API security testing 101. And so we're going to go over some basic things about APIs, security mechanisms, the different ways that you can approach testing an API, and then some examples of some bugs that I have found in APIs. So a little bit about me. I guess I'm a security researcher and an engineer. I work at Zipcar, specializing in web app, IoT, and infrastructure security. And my views are my own and do not represent my employer. So right now, what I'll do, I have this talk kind of cut up into two parts. So the first one is going to be an overview of API attack vectors. And so we'll just go through some of the basic things that some of you may or may not know, and just talk through them with some famous examples from recently. And then the next part, I will talk about the bugs that I actually found. So the first thing to kind of go over is common API security issues at a glance. So one of the things that I like to note to people is that API bugs are a very common source of a lot of the news that we hear about security holes or people being able to access things they weren't supposed to. Everything from Twitter to Facebook to Google Plus to smaller companies, we see a lot of things about the API was misused or mishandled or access was given where it wasn't supposed to. And so those kinds of things are really in the public sphere now. So I like to share this kind of information with people when they ask about those bigger news stories. So security issues and vulns of APIs typically fall into a few distinct categories. So there are a bunch more, but the core ones that I wanted to focus on today were access controls with authorization and authentication, rate limiting, input validation, HTTP methods, and third-party API abuse, and then some other application and logic errors that are kind of sprinkled throughout. So the first one that we'll discuss is access controls. So from the basic get-go, we'll do some definitions here. So authentication involves proving that you are who you say you are, whether you're an admin or a guest or a developer. Authorization involves granting access to the resources that you requested based on your identity. And so access control schemes tend to follow a pattern. Now, this is very general. It's not really pointing to any specific type of application, but usually a client or a user will make a request to something that requires authentication of some sort. The server will process that request and will check for a few things. So those are if an account or session already exists in a database, or if you've already been on the site before, if the requested resource is actually within the access scope of the client. So are you actually authorized to view whatever resource you're requesting? If there's any other previous cookies or tokens that were used in the request that maybe point to you having that authorization already. If their way to the, or if the if the route to the resource is actually valid. So how did you get there? Did you get there from Google dorking, or did you get there from within the application itself? If any other conditions, and then any other conditions the server might expect beyond this. So if successful, the server will give you a token or a session ID or any other identifier to mark who you are throughout the session. And then any other requests that need to be authenticated will follow this pattern again. And so some common ways that people test for access control bugs include enumerating potentially restricted endpoints. So anything in the admin scope, developer, test, any internal API endpoints, modifying session tokens. So either reusing or modifying them in some way, or putting junk data in there. Attempting to bypass restrictions on access with IDOR, indirect object reference, and modifying your request with additional parameters. So people like to put things like admin equals true or test equals 1 or things like that. And modifying refer headers that the application might expect. So you can actually spoof those and say that you came from some other part of the application. So a famous one from this past year was Panera Bread. So Panera Bread had the API endpoint expose that allowed for access to client information. So this was, credit cards and, usernames, emails, addresses, and all sorts of other info. And the client records were sequentially numbered, so it was quite easy to enumerate the entire database by just incrementing. And I think that, I forget what the actual amount was, but there was tens of millions of client records that were leaked through this. And so this is an example of just an access control bug where this definitely wasn't supposed to be something that a normal unauthenticated user was allowed to access. This should be strictly for developers and authorized people. So the next bug class that we have here, input validation. So input validation is super important, and it's something that a lot of people usually consider when they are hunting for any kinds of bugs. But it's very, very critical to remember that input is anything that the server takes in, whether it's from a user, third-party apps, or other internal mechanisms. So common places to test input validation in an API would be within the request header, parameters within the URL, parameters within the request, like we said before, file uploads, which are very, very important ones as well to play with, and different request methods too. So depending on the architecture of the application, specific parts of the request may be processed in unsafe ways. So you see this with any sort of web application, whether it's a API or an older application. But the common bugs would be improper parameterization of requests within the application logic. So are they just concatenating variables in input together and treating all input as trusted? Lack of input sanitation and escaping unsafe characters and all sorts of other sanitization techniques, improper handling of parameters, which actually we'll get to in a second, and insufficient controls for data types passed. So can you pass, a PDF or a zip file, or can you pass a bunch of Unicode, and is that properly handled? So another famous bug is an input validation bug that I thought was really interesting. So Germany has an EID system that allows for people to identify or use their real life identity online. And so some people had tested this, and they found that the requests to the EID system required requests to be signed, which is great access control and input validation. And so the application didn't account for the same parameter occurring multiple times. So if you were to put and user equals Andy and then end user equals Sam, it would process the last parameter that was passed to the application. So it allowed for an attacker to get their initial request signed and processed, and then piggyback onto the request with another parameter, which means that they would be able to do things like change their identity entirely within the system. So this person was able to actually change their first and last name within the German EID system using this. And so I'll have the slides available, but there's an awesome YouTube video and a blog post about it that you can read. So common ways to test fuzzing. There's a lot on here. There's things you can fuzz for, which are things you normally fuzz for in any sort of application, which is remote code execution, cross-site scripting, local and remote file inclusion, SQL, NoSQL injection, request splitting, deserialization, XXE, and anything else with templated languages, encoding errors, which is another favorite of mine, with junk characters, control characters, emojis, and Unicode points that don't have any data associated with them, which is another thing that applications sometimes forget to include processing for. File upload vulnerabilities, which would be, can you upload something with a GIF header that's actually PHP or JavaScript, and things like SSRF. And so tools that are commonly used for these kinds of things are burp, which is the gold standard in my view for fuzzing and using the repeater to insert junk data into requests. Other enumeration tools like GoBuster, Dirbuster, using set lists and other GitHub repos that have a lot of awesome fuzzing payloads, as well as just general application parameters that might be useful. And then custom scripts, which I'll get into in a little bit too. So pro tip here is speed up your fuzzing by making head requests to API endpoints, which I'll also get into later. So rate limiting. So rate limiting is something that I think doesn't get as much attention as it should in a lot of applications, because APIs are built to expect a high load and a lot of requests. And so this functionality of it can be actually used against it and be used to quickly enumerate an endpoint. And so there's a lot of common ways to test for rate limiting. So you can make a bunch of requests and see what happens, and check the headers to see if you get any responses back that are rate limiting tokens. But you can also try to make requests in varying states of authentication. So sometimes rate limiting bugs only happen, or you are only rate limited if you are at a certain access level. So you can try as an unauthenticated user, authenticated as a developer, as a bot with a deactivated account or user, or with just bogus fake credentials in general. So an API with improperly implemented rate limiting can be used to make an abnormal amount of requests and actually cause other issues like DOSing as well. Restricting API or HTTP methods is another important thing to consider here. So applications are built to support a lot of different methods for different purposes, whether it's for inserting client records or accessing, modifying certain things. You can do put and delete requests. And some of these methods can be accessed unauthenticated, and sometimes the scope of the HTTP methods is actually beyond what the application actually expects. So there might be something that you can do a put request on or a delete request on that is actually a get or a post parameter. And you basically would be able to find undocumented features of the API with this. So it's always good to look at the API spec and documentation and see what actual methods are requested and compare them to what HTTP methods are actually allowed based on what the server tells you. And so even if they're not included in the application logic, if an application is lazy with the way that it parses methods and has no logic to parse anything, really weird things can happen. So the next thing that I have here is third-party API abuse. And so APIs sometimes call other APIs to do what they need to do. And so the relationships between a target API and third-party APIs is typically trusted in some way. And so because there's an implicit trust between different APIs in certain scenarios, either can be leveraged to access privileged resources. And so there are some common ones here, like request splitting to make additional requests to a third-party API through a target API. Server-side request forgery, so you can use the API to resolve a URL and trick it into making requests in the context of the server itself. So you can use it to enumerate the internal network or gain access to server metadata. And then unhandled input from a third party. So sometimes you might make a request to your third-party API that gives back data that was unexpected, and it can cause unexpected outcomes within the target API that you're testing. So I have some examples here that kind of tie into the bugs that we just discussed. So I'll kind of highlight them as I go through them. So the first one here is within Discord. And so Discord has an API that is very, very robust. It has a lot of data types that can be passed to it, a lot of parameters, and a lot of access controls on it. And so with a partner of mine, we were testing out the Discord API to see what kinds of requests you could actually make and to see how they are implemented within the application. And so we were testing the invite scheme. So there's, when you are inviting somebody to a Discord server to chat, you create a either a one-time use invite code or a invite code that doesn't expire. And so we found that the invite scheme for direct messages was the same as those for server invites. And so we were playing around with it just in Burp, and we found that the DM invite codes are actually only used internally and assume that a user is already authorized to be in a group DM if an invite is actually used. And so Discord also had two APIs available to test all this stuff out on, an older one and a newer one. And so that's another important thing to remember when you are looking at APIs as a whole is, are there more than one? Is there a development one? Is there one that is deprecated and for some reason still available? Those are all really important things to consider. 1 second. So our methodology here was we had written a script to enumerate invites. And so we made requests to the API to see if an invite code was valid. And you can actually figure out whether or not a code is valid by just making a head request and reading the response. So from this, we were able to make about 100 requests per second, and we found about 1 valid invite per minute. And we randomly generated invites rather than trying to brute force the entire key space, because an invite code is 6 characters long, it's alphanumeric. And so trying to brute force that from the beginning would take a while. Still doable, but we felt it would be better to just try to randomize it. And we ended up finding out that generated codes seem to be used as seeds for future codes. So we actually were taking valid codes and then changing parts of the code itself to check for further codes. And we only enumerated temporary invites, which are 6 characters, although there are long-term invites, which are 8 characters long. And so here's an example request. We had successful requests versus failed requests. So you're making this curl request. This is unauthenticated as well, to the Discord API with an arbitrary invite. So the one on the left is LOL yes, and the other one is LOL no. So the LOL yes one gives a 200 response, and the failed one gives a 404. So it's easy to write a quick Python script to be able to enumerate these things and see which ones were valid and which ones weren't. And so the impact for this was we were able to join private servers as well as private group DMs. So the DMs were strange, and I actually wish I had a screenshot included in here, because it looked the same as a server invite where you are invited to join a specific server, but it just had a list of usernames in them, and you could just join, and people were pretty freaked out when we found out about this. But it's interesting because as researchers who don't really hang out on Discord that much, just jumping into a random group DM was kind of funny and weird. So yeah, the next one that I have is Duda Mobile. And so if you haven't heard of Duda Mobile, it's a website templating service that people use to make mobile websites for their desktop website. And so it basically it takes an existing website and it turns it into a mobile-friendly template. But it also has an API that's built in to process external links and convert them into a mobile-safe format. So it tries to script some JavaScript and CSS and attempts to load the website into the preset theme, which is interesting. So right off the bat, I was able to, in testing this, to get past the filtering mechanism and bypass JavaScript filtering with onload directives and image tags. But I could also access the mobile site's internal rendering API to load other APIs within the context of this website on their platform, or any website on their platform. So there was about 30,000 websites, and you could do the same thing to just load arbitrary URLs into the template of the website. And so this allowed for SSRF attacks also on Duda's infrastructure, as well as loading some of their internal resources as well. And so that's just the URL scheme is down there. So it led to things like this: the Duda Mobile API being used to access internal resources. This is a router at 192.161.1.1. And yeah, this one I wasn't able to actually sign into, but the fact that I could then use this to enumerate the rest of the network, it's pretty scary. But the real scary one is being able to load their AWS keys into any of the Duda Mobile websites that were templated. And so this is an example of being able to use one API to call another API and be able to enumerate information from there. So the impact was it led to the disclosure of private AWS keys and sensitive information in the production AWS account for the whole enterprise through SSRF. I was able to load and potentially modify internal router configs and other resources by accessing these. And it was definitely a really interesting bug to explain. And so with that, it's 20 minutes. If you follow up with me, if you have any questions or comments or concerns, feel free to email me at blackhat@zipcar.com. Also, if you are a security-focused developer, we are hiring, and so you can hit me up as well to the resume if you are looking to get into the space. So with that, I ask if there's any questions from the chat. Somebody in the chat asks if there's any additional resources for reading about API hacking. I mean, a lot of the stuff that I've looked at has mainly been like OWASP stuff as well as just random blog posts. So a lot of this sort of thing is just stuff that I've ended up doing at work or through other testing. So I would just Google API hacking, I guess. So be my go-to thing unless somebody has other things.